My name is Ashley, and today I'll be going over the endosymbiotic or symbiosis theory. First thing that I would like to do is break down the word endosymbiosis. First off, the word endo, it means inside. And I put down this example of a door. You go in, when you see a sign that says enter, you go inside the door. The opposite of endo, you probably have heard in biology, exo. Exo means exit. If you see a door with the exit sign on top, you go out of it. So that means outside. So in this case, we're using endo, like I said, and we're going inside something. We're entering into something. Okay? Next part of it is symbiotic or symbiosis, which is the symbiosis is living basically close together. The example that I have down here is you probably have all seen Finding Nemo. Okay, in Finding Nemo, the clownfish stay very close to something. It looks to me like green fungi. It's actually called sea anemone. The clownfish rolls around in, and it as it rolls around in, the sea anemone cleans the clownfish, and also a pro to the sea anemone is that it gets some good food as it cleans the clownfish. So that is an example of two things living close together, which brings together the word endosymbiosis, which means living close together, being inside of something. An example bringing them close together will be E. coli inside of a human stomach. What the gut of the stomach gives the E. coli is a safe place to live, as the E. coli gives the gut vitamin K. So it's in our gut, we're living very close together inside the human body with E. coli. So it's like a win-win. And like I said again, putting it all together, endosymbiosis basically means living close to something, inside of something. I know I said a lot, so let's break it down to see what does this all means. Well, I have this example, and when I was doing research, it was a very clever way that someone else broke down for me. So I'm going to use their examples, changing it up a little bit. Okay. You have right here Big Sam as an example. Now, Big Sam is your eukaryotic cell. It is just a big, huge cell. The pro of this cell is that it is big, but the con of this cell is that it's slow and tired. Now, Big Sam has two friends. Now, these two friends are prokaryotic organisms, okay, as Big Sam is a eukaryotic organism. Now, the first friend that we have is Small Tom and Small Tim. Now, Small Tom is known as your aerobic bacterium, which later down the line turns into your mitochondria. Now, with Small Tom, it releases energy. That's why you have the lights and everything coming from it. It releases it gives off energy, so it's energetic, very energetic. Now, with small Tim, it makes its own food. So you have, what is it called? Can never say this word. Is Cyanobacterium at its first stage, but later down the road it turns into chloroplast. Okay, so chloroplast, it makes its own food. It gets its food from photosynthesis. So you have your two friends. Now, those are the pros of the two friends, but the con, of course, is that they're both very fragile. So everyone is not looking so happy. And when they replicate, they don't replicate anything else. They replicate small of the same. They replicate their same body. You have down here Big Sam replicating more Big Sams, and his friends Tom and Tim replicating little Toms and Tims. Well, Big Sam got an idea one day. He got an idea. He went to his friends with the idea and said, hey, why don't you two, Small Tom and Small Tim, why don't you all live inside of me? I will give you a house to live in, and I also will protect you. I'm big and you'll be comfortable in there. Of course, they said, you know what? Sure. We're small, very fragile. We need someone big that we can live in and that can also protect us. So they, one by one, they enter into Big Sam. Okay, and here, as you see, they are all happy together, which gives us our endosymbiosis theory. Your organisms living inside of each other, closely inside of each other. Now that we have this wonderful family, the pros is that it's big, it makes its own food, and it's very energetic. Of course, the only con is that it gets bored. So what it does is find other cells identical to them and clumps together and lives with them. Kind of like you go into a little house party and you like hanging around clumps of people. So that's what this cell did. It found more friends just like them and hung around them close together in clumps. Now, evidence of being in the endosymbiotic system, as far as referring to the prokaryote cells, are that it has DNA, 70S ribosomes, double membrane. It has a size to it, and it has biofusion and replication, and also a location that is called electron transport location, which